So the next thing we're looking at is solving 1- and 2-step equations. So that should be in our table of contents underneath simplifying expressions, and it is page 14. And then when we glue that into our interactive notebooks, we'll have this site here on our left and our second page over here on the right. So go ahead and pause it if you need time to get that put in. So if we want to solve 1- and 2-step equations, we are going to do that by using inverse operations. Okay, inverse operations are operations that will do just that. They undo each other. Inverse is undoing. Okay, so our inverse operations are set up that addition and subtraction, right? Those are partner operations. They inverse each other. They will undo each other. And multiplication and division go together, right? They will undo each other. So when we are balancing an equation, or when we're trying to solve an equation, we are going to do the operation, whatever it is that we decide to do, to both sides of the equal sign. Okay, because our whole entire point is that we want to balance it. So whatever we do to the right, we have to do the exact same equivalent thing to the left. Okay, so with that being said, realistically, we can do whatever we want to either side of an equation. So I could decide no matter what equation I see, I'm going to add 17 to both sides. Or I'm going to multiply by -22 each time. Okay, the key is that, though, we want to be able to strategically pick what we do to both sides so that we're able to get the variable by itself. So, for example, if we look at x plus 17, if I want to solve x plus 17, I'm going to do that by trying to get x by itself. Okay, so I'm going to look at the side of the equation that the variable is on, and I'm going to realize that over here attached to it is a 7. We undo adding 7, right? We undo addition with subtraction. So whatever a sign we see here, we want its inverse operation below it. Okay, so I'm going to subtract 7. And like I said, right, here's our equal sign. Whatever I do on one side of the equal sign, I have to duplicate that exact same process on the other side of the equal sign. So we then know that these two things cancel each other out. 7 minus 7 is 0. Those go away. And the only thing we're left with is x. Our equal sign always comes straight down. And then 17 minus 7 is 10. Okay, so we'll see that same thing over here with y minus 5 equals -3. So if we want to get this y by itself, okay, we're going to look on that side of the equal sign. The 5 is what's sitting over here with the y. Okay, so if we want to move this 5, we want to use the inverse sign. So this is subtraction, and we undo subtraction with addition. So I want my inverse sign right underneath it, and I'm keeping that number the same. This is my equal sign. So I'm then going to bring over and add 5 to the other side as well. Okay, these will then cancel out. I have my y left, and then I'll just take -3 plus 5. -3 plus 5 gives me a 2, and so I'll get an answer of y equals 2. Okay, now when we are dealing with multiple signs happening, there are a couple ways that we can address this. There are a couple options you could sort of go with. Option number 1 is that you can stick to the exact same process that we've been doing. Okay, this process says, here is my variable, and the number that I want to move is -4. Okay, so I'm looking at the sign in front of it, which is subtraction, and my inverse operation to subtraction is addition. So I know underneath my operation, I want to put addition. And then just like this was a 7, so I brought a 7. This is a 5, so I brought a 5. This is a -4, so I'm bringing a -4. And whatever I do to one side, I'm doing the exact same thing to the other. So I know these will cancel out. My x is coming down. And my 12 plus -4 gives me an 8. And if you're not sure what 12 plus -4 is, right, that's why we've talked about how to use the calculator. Just put that in your calculator. Okay, number 4. So now our things aren't quite in the same order, but we still have our variable over here on this side, so we're going to focus on the left-hand side, and we know that we want to move this 17. Now, every time, we haven't mentioned it, but every time we've looked in front of the number, in front of the number, in front of the number, that is always the process. We need to look in front of the number. Okay, and in front of that 17 is a negative sign. And you might go, but that's a negative sign, not an operation. But a negative and a subtraction look an awful lot alike, right? And so our inverse of subtraction is addition. Whatever we do to one side, we also have to do to the other. So we know our 17s will cancel out. And then we're just taking 30 plus 17, which will give us a 47. We can also have multiplication and division. We still are following that same idea. So we're going to look at the side that the variable's on, and we're going to decide what our operation is. We need to get rid of this 7. And when we don't see an operation happening that's really multiplication, we undo multiplication with division. Okay, so I'm going to undo multiplication with division. Whatever I do to one side, I have to do to the other. Now, notice I'm writing my division sign as a fraction bar. I really, really strongly encourage you to get away from writing any type of division sign like this and using that fraction bar. Okay, negative 28 divided by 7 is going to give us a negative 4. Number 6. Our variable's over here on this hand side. Okay, so we need to get rid of this 4. The operation in between them is a fraction. A fraction is the same thing as division. Okay, so we're dividing. We undo division with multiplication. Now, just like I'm saying use that fraction bar for multiplication, it's a much better habit to get away from using an X for multiplication and think about multiplication as something with parentheses that we sort of do in front of something. Okay, so we're going to multiply by 4 on each side. I do it on the left, I have to do it on the right. So these 4s are not getting multiplied as 4 times 4, right? I really have a 4 over 1 and an n over 4. And if one's in the top and one's in the bottom, those cancel each other out. Okay, so I'm left with an n equals 6 times 4, which gives us a 24. On our next problem, number 7, we have a couple options that we could use to solve this. Okay, option number 1 is that if you remember from middle school talking about using the reciprocal and multiplying by the reciprocal, by all means, go for it. If you're like, I have no idea, I really don't remember what to do, we're just going to be consistent with our rules. So if we look over here where the x is, okay, these are two values that are being multiplied together. So we have 1/3 times x. We undo multiplication with division. So I said I'm going to use a fraction bar for my division. And since I was multiplying by 1/3, I'm now going to divide by 1/3. Okay, my 1/3s will cancel out. If you don't know what 5 divided by 1/3 is, use your calculator. Okay, but for those of you who remember that it's multiplying by the reciprocal, right, this would be the same idea as multiplying by 3 over 1 in here. Okay, that's going to give us an answer of 15. Now, there's also a possibility that our variable is going to be on the other side. Do not let that mess you up. Okay, you're still going to focus on the side that the variable's on. Okay, this is multiplication happening in between it. To undo multiplication, we said we would use division. So if I'm going to divide by negative 16, I'm keeping that number the same. I saw a negative 16, I'm dividing by a negative 16. I'm going to do that exact same thing on my other side of the fraction. Okay, and then when I divide, negative 48 divided by negative 16 is going to give me a 3. My 16s are canceling out, and I'm left with a y. Now, while I would give you full points for this, we tend to write this with our variable first, and so we flip it and say y equals 3. Now, we can also do this when there's more than one number happening on the same side with the variable. Okay, and the key is that we want to do order of operations backwards. Okay, so we want to undo in the reversed order of our order of operations. So if it was PEMDAS, oops, I forgot my D, we now want to do SADMEP. Clearly I made that up. That's how I'm pronouncing it, doing it backwards. Which means we're going to undo any addition and subtraction first. So if we look at number 9, okay, if we look at number 9, we're looking at the side that the variable's on. The first thing that we want to do is see if there's any addition or subtraction. Okay, and we're going to undo that first. So over here, I'm adding 10, so I'm going to undo my 10. We said we would undo addition with subtraction. And whatever I do on one side, I also have to do on the other. So I know my 10s will cancel. Okay, but now instead of just having a variable come down, I'm having a 2x come down. 24 minus 10 gives me a 14. So I'm not done. So now I have a step 2 that I have to consider, right? Which is going to be now to think about my division and multiplication. So now I'm going to undo any multiplication or division. Okay, so just like we were practicing, right? When I look over here, this is multiplication. I undo multiplication with division, and I will get a final answer of x equals 7. Number 10, again, doing order of operations backwards. Our first step is that we want to undo any addition or subtraction. So when we look over here, this 3 is being attached with multiplication. This 16 is what's being attached with addition or subtraction. So that's what we need to undo first, this 16 first. But just like we said over here, we always look in front of it. So we want to look in front of it to figure out our sign. Okay, addition and subtraction we're looking in front of. So if this is a positive 16, we are going to undo that with a negative 16. Whatever we do on one side of the equal sign, we have to do on the other. So now we'll have a 3x equals a negative 6. We're now left with multiplication. We undo multiplication with division. Okay, our 3's cancel out, and x equals negative 2. Now, number 11 is a very unique situation. If we follow our rules and we say, well, we're doing order of operations backwards, it says to undo addition and subtraction first. And so my students say, okay, well, I'll undo adding 5. But we have this small dilemma here, okay, that this really has multiple things happening in the numerator. This fraction has more than one thing sitting on top of it, which means this stuff is really held in parentheses. And if we're doing SADMEP, parentheses now come last, which means this y plus 5 are stuck together by parentheses, so I need to move this 4 first. This 4 is attached by division. We undo division with multiplication. So I'm going to multiply each side by 4. Okay, that 4 just cancels with the denominator. It does not affect the y plus 5. So I'm bringing down my y plus 5, which gives me a 12. Okay, and now those parentheses can come off because I'm not in that fraction anymore. And now I can undo my addition with subtraction. And so I'll get y equals 7. And then finally on our last problem, okay, again, even if we say there's a fraction, there's only one thing sitting on top, so those parentheses don't really matter. So we're going to undo addition and subtraction first. So this negative 3 is held on with division. The 9 is held on with addition. We undo addition with subtraction, and whatever we do to one side, we have to do to the other. So those are going to cancel each other out. Okay, I then have an m over negative 3, and 11 minus 9 gives us 2. And then our final step is, right, we will undo our division with multiplication. And so we will get m equals negative 6.